Good day everyone. Today we're going to learn about the line balance ratio. Line balancing, a production strategy that involves setting an intended rate of production for required materials to be fabricated within a particular time frame. In addition, effective line balancing requires assuring that every line segment's production quota can be met within the time frame using the available production capacity. The goal of line balancing. First, to improve efficiency by eliminating bottleneck processes, reduce the pitch time, and increase capacity. Second, to eliminate idle time, work in progress, and lessen operators' fatigue by redistributing operators' workload and processes. The line balance ratio. It measures the evenness of operators' workload and processes across the production line. The ideal line balance ratio is 100%. The target line balance ratio is 90%. Line balance ratio is also known as workload balance, line of balance, or simply line balance. The formula is line balance ratio is equals to sum of all process cycle time over the product of pitch time and total number of processes multiplied to 100%. This illustration shows the difference between the smooth flow and the restricted flow. Definition of terms. Cycle time. The time it takes to complete the process from the first task to last task. Pitch time. The longest cycle time in the production line reference to the available time. Work in progress. Products that are being or waiting to be processed, usually between processes or production lines. Unit per hour. Measures the number of completed units realized per hour of work. Bottleneck. A constraint in the production system which has the lowest capacity or the longest cycle time which determines the maximum throughput. Bottleneck prevents smooth flow of products, creates inventory buildup, and idle time. In worst condition, results to delay in deliveries due to capacity issues. Next, we have the line balance ratio case. An electronics production line has the following processes with their respective cycle time. Process A, crimping, has 32 seconds. Process B, 5 bond and 2 bond wire soldering, has 46 seconds. Process C, 7 segment display soldering, has 34 seconds. And process D, PCB inspection and testing, has 37 seconds. Note that soldering operators Rika and Mela are skilled to handle either C or D process that has the same workstation setup. For our line balance ratio case, we need to answer the following questions. A. Compute the line balance ratio. B. Which process is expected to accumulate work in progress inventory? C. What can you propose to improve the line balance ratio to 93%? And D. Show your simulated line balance ratio computation for your proposal and its impact to efficiency, unit per hour, and 8-hour shift capacity. Let's compute the line balance ratio, the formula, the given. Then, let's substitute. So, we have the sum of all the process cycle time, the 149 seconds, and the product of pitch time and total number of processes, which is 184 seconds multiplied to 100%. The line balance ratio is 80.98%. So, the result shows that it is below the ideal or the target ratio. For the question B, which process is expected to accumulate work in progress inventory? The process B is expected to accumulate work in progress inventory for it has the longest time cycle. Next question, what can you propose to improve the line balance ratio to 93%? To improve the line balance ratio to 93%, we need to reduce the process time of process B from 46 seconds to 40 seconds and increase the process time of process C and process D by 3 seconds. Since soldering operators Rika and Mela are skilled to handle either process C or process D. For the last question, show your simulated line balance ratio computation for your proposal and its impact to efficiency, unit per hour, and 8-hour shift capacity. So, the table shows the given. Next is the formula. Now, let's substitute. The sum of all process cycle time is 149 seconds over the product of pitch time and total number of processes, which is 160 seconds, multiplied to 100%. So we have here 93%. The result shows that the line balance ratio increased to 12.15% from 80.98%. For the unit per hour, we have here the formula. Unit per hour is equals to 3,600 seconds over pitch time. So before, we have a pitch time of 46 seconds and the unit per hour is 78. Then we have the after. The pitch time is 40 and our unit per hour is 90. Computation shows that there is an increase of 12 units per hour. For the per 8-hour shift capacity, we have before the 624 and after we have 720. The computation shows that there is a 96 increase in capacity equivalent to 1 hour of production. Shown is the summary of improvement. The line balance ratio before is 80.98%. But after we reduce the process B from 46 seconds to 40 seconds and increase the process time of process C and process D to 3 seconds, we come up with a 93.13% line balance ratio. And also, there is an increase in unit per hour from 78 to 90, which means there is a 15.38% increase in unit per hour. For the 8-hour shift capacity, from 624, it increases to 720. So there is a 96 increase in capacity. I hope that you've learned a lot from this video. Thank you for watching.